Introduction to Machine Learning. Machine learning is a branch of artificial intelligence that enables computers to learn from data and improve performance without being explicitly programmed. Instead of following fixed rules, machines identify patterns and make decisions based on experience. This foundation helps systems adapt, predict outcomes, and support decision-making across many industries. Why machine learning matters. Machine learning is important because it allows organizations to process large amounts of data efficiently and extract meaningful insights. It powers everyday tools such as recommendation systems, fraud detection, medical diagnostics, and speech recognition. Understanding its basics helps interns see how technology transforms real-world problems into automated solutions. Machine learning versus traditional programming. In traditional programming, developers write explicit rules and logic to solve a problem. In machine learning, the system learns rules automatically from data and examples. Instead of coding every condition, we provide data and expected outcomes, allowing the model to discover patterns and make predictions on new data. Types of machine learning. Machine learning is commonly divided into three main types: supervised learning, unsupervised learning, and reinforcement learning. Each type differs based on how data is labeled and how the model learns. Understanding these categories helps in selecting the right approach for different problems and datasets. Supervised learning. Supervised learning uses labeled data, meaning each input has a known output. The model learns by comparing its predictions to the correct answers and adjusting accordingly. Common examples include spam detection, price prediction, and image classification, where accuracy improves as more labeled data is provided. Unsupervised learning. Unsupervised learning works with unlabeled data, where the system does not know the correct output in advance. The goal is to discover hidden patterns or structures in the data. Examples include customer segmentation and anomaly detection, where insights emerge without predefined categories. Reinforcement learning. Reinforcement learning focuses on learning through interaction with an environment. The model takes actions, receives rewards or penalties, and learns over time to maximize positive outcomes. This approach is often used in robotics, game playing, and autonomous systems that require continuous decision-making. Key components of machine learning. Every machine learning system relies on data, algorithms, and models. Data provides examples, algorithms define how learning happens, and models represent learned patterns. Together, these components allow systems to process inputs and produce meaningful outputs through training and evaluation. Understanding data in machine learning. Data is the foundation of machine learning and directly affects model performance. It can be structured, like tables, or unstructured, like text and images. Clean, relevant, and well-prepared data helps models learn effectively, while poor data quality often leads to inaccurate predictions. Features and labels. Features are the input variables used by a machine learning model, while labels represent the expected output. Choosing meaningful features is critical, as they influence how well the model understands patterns. Feature selection and engineering are essential steps in building reliable models. Training and testing data. Data is typically split into training and testing sets. The training data teaches the model, while the testing data evaluates its performance on unseen examples. This separation helps measure how well the model generalizes and prevents it from simply memorizing the data. Machine learning models. A machine learning model is a mathematical representation learned from data. Examples include decision trees, linear regression models, and neural networks. Each model type has strengths and weaknesses, and selecting the right one depends on the problem, data size, and desired accuracy. Model training process. Training involves feeding data into the model and adjusting parameters to minimize errors. The model learns iteratively, improving predictions over multiple cycles. This process continues until the model reaches acceptable performance or stops improving significantly. Overfitting and underfitting. Overfitting occurs when a model learns the training data too well and performs poorly on new data. Underfitting happens when the model is too simple to capture patterns. Balancing complexity ensures the model generalizes effectively and remains useful in real-world scenarios. Model evaluation metrics. Evaluation metrics measure how well a model performs. Common metrics include accuracy, precision, recall, and mean squared error. Choosing the right metric depends on the problem, especially when errors have different levels of importance in practical applications. Real-world applications of machine learning. Machine learning is used in healthcare, finance, education, transportation, and many other fields. It helps predict diseases, detect fraud, personalize learning, and optimize logistics. These applications demonstrate how theoretical concepts translate into impactful solutions. Ethical considerations in machine learning. Ethics play a critical role in machine learning development. Bias in data can lead to unfair outcomes, and lack of transparency may reduce trust. Responsible use includes ensuring fairness, privacy, and accountability when building and deploying intelligent systems. Tools and libraries for machine learning. Popular machine learning tools include Python libraries such as scikit-learn, TensorFlow, and PyTorch. These tools simplify model building, training, and evaluation. Understanding available libraries helps interns work efficiently and follow industry best practices. Learning path for machine learning interns. Interns should start with basic mathematics, data handling, and core algorithms. Practicing with real datasets strengthens understanding and confidence. Continuous learning, experimentation, and collaboration are key to developing practical machine learning skills. Conclusion and key takeaways. Machine learning enables systems to learn from data and improve over time. Understanding its fundamentals prepares interns for advanced topics and real projects. By mastering data, models, and ethics, learners build a strong foundation for impactful and responsible innovation.